Okay, so we're going to knock out 2 in 1 here. We're going to talk about how to find our arc length and our surface area. Well, we're already going to kind of know the surface area formula. The arc length is going to be a little bit different on this one. I'm not going to derive it. I'm actually just going to give it straight away to you. We're going to find the length of the curve. And we're going to say that the length of a curve is going to be, we're going to say from alpha to beta instead of A to B, so we don't confuse alpha and beta, because that's in T, not in X's. Just being real careful with that. So then we're going to say it's the square root of something squared plus something else squared, and you guessed it, dx dt all squared plus dy dt all squared. And that's going to be with respect to t. Now there are some caveats to this, and our theorem will tell us that the curve C is described by the parametric equation as x is equal to some f of t. Hey, we got that, and some y is equal to some g of t. Then from alpha to beta, where f prime and g prime are continuous on alpha to beta, closed interval, and c is transverse exactly once. So this is only one time we're going around, one time, exactly once, as t increases from alpha to beta. Then the length of c is, there we go. So make sure to read your theorems. There's little things that are in there that make all the difference in the world. So let's tackle our problem here. There's not going to be too much for us to do. Our alpha to beta is going to be 0 to 2 pi. So we integrate that. Now we're going to take the square root of something squared plus something else squared. And I'm pretty sure the derivative of r cosine of t is going to be negative r sine of t. And the derivative of r sine of t, well, shit, that's going to be r cosine of t. And remember, the variable is t. That's why we're not taking this on a product or any shit like that. Now we go through the integral from 0 up to 2 pi, the square root of r squared sine squared plus r squared cosine squared of t dt. And we're going to assume, I didn't state it up above, but we're going to assume that r is greater than 0. All right, or we don't have a very cool little circle here. So we'll assume that this is r is actually a little radius. So we can yank that r squared right out of the square root, and it's just going to become r. All right? The square root of r squared is just r, when r is a positive value. So we factored that out, and I factored it just from here and here. They're both there. The square root of r squared is just r, yanked it to the front, and now it just leaves us with sine squared plus cosine squared dt. We know sine squared plus cosine squared is equal to 1, and so it's r times the integral from there to the square root of 1. So that's just, oh, well, let's go. So it's r times, and then that's just going to be t evaluated from 0 to 2 pi, huh? So what's this? This is going to become 2 pi r minus nothing. So, oh, weird. So the length of the curve, or do I mean the circumference of the circle with radius r? Well, we just proved that the circumference of a circle has length 2 pi r. And we got that from our fancy new formula here, huh? There's our fancy new formula for arc length. So get that one down, because now we're going to consider a second problem very, very similar. So we'll break this one down. We're going to say x is equal to r cosine of t. We're going to say that y is equal to r sine of t. But in this one, let's keep our t's in between 0 and pi. Now I'm going to snatch this one straight out of your book. This is the example they use, example 6 for page 654. I'm going to use the same one because I think it's a beautiful freaking example. And I think you'll be able to follow along pretty clearly with it. So we're going to consider this, and we'll do a second one. We're going to want to find, so if we rotate this circle, we rotate this about an axis, just like we did with our surface area before, it's actually going to create a sphere. It's going to create a sphere. So we're going to say, we're going to show that the surface area of a sphere is, what is that, 4 pi r squared. That's right, that's what it is, 4 pi r squared. You might have got that in your related rates. So that's what we want to go find out. So our formula is, it's not that bad. Our little surface area It's going to be 2 pi, but you already knew that. But now we can't take our integral from a to b. We're actually going to need to go alpha to beta. And we're going to call this well, that's going to be y times our surface area. Or not our surface area. Come on, dude. Our arc length. dy dt all squared. There we go. dt. Well, we don't want to write in y, and we don't want all that other nonsense, so we have is equal to 2 pi, and now we're going not from 0 to 2 pi anymore, but we're going from 0 to pi. Now, instead of writing in y, let's write in what it equals. That's r sine of t, huh? Let's get that in there, so we'll put in our r times our sine of t, and remember that we don't have to stress out any about the r. The r is just a constant. We could yank that out right now. And now we're going to do that same process again. We're going to square this stuff up. We're already going to know the answer to it, though, right? We've already done it. Negative r sine of t, and our positive r cosine of t. Sorry, that's a little scribbly, but we've already done that part before. So we clean all of that up. We get this 2 pi r hanging out. We have 0 to pi. We got our sine of t, and then what's this going to become? Oh yeah, we did this before. It just becomes r. It becomes a single solitary frickin' r, huh? Just look back at the prior example, so that becomes 2 pi r squared times 1. There we are, right? Remember that r from back there? Or the r that popped out? That was all it was. Now let's go integrate. So we have 2 pi r squared. And the derivative, oh shit, no, the antiderivative, right? The antiderivative. So that's going to be what? Negative cosine of t, evaluated from 0 to pi. Let's be careful, because there's going to be, I'll bet you there'll be some weird ass sine error in here. So we're going to have negative cosine of pi minus negative cosine of 0. I think we nailed that one, right? So this is going to become 2 pi r squared and negative cosine of pi. Well, cosine of pi is negative 1, and negative 1 is 1. Minus of negative, that's a positive. Cosine of 0 was 1, so we had 1 and 1, and that's 2. We have 2 pi r squared times 2, and frickin' ta-da, 4 pi r squared. But really, what you're looking at here is we want our surface area formula, and we want our arc length formula. We got them both now. I did some generalities. We showed our surface area for a sphere. We also showed that the circumference of a circle by going through this. So get through, use your arc lengths, use your surface areas, do those homework problems. I really like these homework problems in 10.2. They're at a very good level. And I hate to do it to you, but you might want to do the ones with the frickin' words too. I mean, maybe not the one that says Simpsons roll on it or any nonsense like that, but shit. Couldn't hurt to learn about Maria Agnesi or something like that. Couldn't. Maybe find the exact area of the surface area. Good shit. Well, go take a look. Figure your shit out. See you soon.